this is the level we've seen. This is basically my layout. Now, let's start with the inventory. So let me just bring it here. Right. So this is the dialogue system, which you may have seen before. This is made by Not Yet, and you can get this on the Epic Marketplace. I think it's now something like $9 or something. And I actually like this one a lot. But let's start with this. Okay. So this here is a wrapper, and so when we make our items, they go into this they go into this little wrapper. The item itself is this. This is stretched because it's of the way it works. But when it does work, it's basically, where are we? Yeah, here we go. So we're in set values. When we create this item, we basically will. In fact, let's start from the very beginning. So to start off with, we have this. This is our inventory structure. So what we have a bunch of different variables that we can list together, and this on its own is there's nothing for it. But the reason why this is important is because the next thing we needed is the item data table. Now, what in this, I sort of made a whole bunch of things that maybe we might need or we might not need, but in general, all we needed was the item name, the description, and the picture. Those are the only things we're using. And we can adjust them for all of the different items, basically. Actually, I think we do need the enumeration. No, we don't. We didn't use the enumeration. But yeah, so we have a list of items here, and the next thing is in the inventory. Yes. In fact, no, it's in the third person character. So when we come to these in our dialogue system, that we have the dialogue system's got an event. So in this case, we have our participant, that's the player, which runs in the third person character, and we have our event give debug. So we go there and look at the events, which are here. We have give debug and give the other bug, and then a whole load more that are not relevant to this one right now. But up here, we have basically an unlock items graph. Now, if we open up that graph, which is here, all we do is we feed in the number of the item that we want to unlock. We then check against an array, which will show you what that was, if that item has already been unlocked, and if it's... Oh no, so this is that one. So yeah, we have an items unlock. Okay. Unlock items will basically send the item through to this array, and this array will then update to say, yes, we now have this item. Now, the item itself is here. When we start the level, we firstly gain we pick up the item data table that we were talking about, and we get the basically get the row names. So we have all the various different rows and set them up in a new array. We also gain the length of that array and use that to resize our items unlocked array. So what we have then is an array of items the same length as an array of balls. And because they're the same length, we can now associate them with those various things. We need to be careful that we make sure we put things in the right order when we do this, but otherwise it's there. So when we looked back at this, we could see we had 1 and 2, which, because it's all 0 referenced, we have 0 and 1, which leads to our third person character, 0 and 1. That's how he unlocks our items. So when we press our inventory key, so in this case it was G, firstly we check to see whether or not well, I've basically discovered that. So this is my gate, this is the flip-flop node. The flip-flop node is the same as this gate. So I decided not to use the flip-flop because this node works just a little bit better. It was a little bit cheaper, basically. So firstly we check if the inventory is open. If the inventory is open, we will close it and remove the widget from the screen. If it is not open, we open it and create the widget based off of our off the inventory that we've had up here, and then we shall add it to the viewport. So we're now back here in this viewport. Now we have our graph. So this is event construct. When we construct the the inventory, it'll run all this code. So firstly, we cast the third person character so we can gain the variables that we need to check against. So in this case, it's which items are unlocked and also the agility stat. We then take the data table row names, and then for each of them, we first check to see whether or not the item that we're trying to unlock is unlocked. If it's not unlocked, then we don't do anything. If it is unlocked, so have a true next to it based on the index, that's why the index needs to stay the same, we then get the actual row on the data table based off of the name that we have already established in our array previously. And then we break out into the various stats. We then create the new item widget, which we can assign, or which we then set the values on based on here. And finally, we add it to the inventory, which we set up previously. Once that's complete, we also can run any other code. So in this case, what we do is we run our agility bar, which is just a percentage bar, and we set the percentage based on the agility stat. So the agility is a integer of 1, so we times it by 0.1 to turn it into a percentage, because it'll be between 1 and 10, no more than that. And then we can just draw it onto the screen. And that, in short, is how the inventory works, which I, again, proud of and was very confused in trying to say that. I might just cut this down and just release the first part of the video, but oh well. The next thing I was working on this week was the new camera system, which is complicated. So the old camera system was a lot simpler, but it had those problems. So I suppose I'll just read through the comments sections here. So start off with, we need to create a bunch of vectors that will be our start and finish nodes, or start and finish world positions for the ray trace. So what we have here is we have our player location, and then we have a little item which is always 1 meter ahead of them, and that's basically 1 meter ahead of them based on whichever way they're facing. So that is we'll get both of those. We then break them apart so we can mix and match. The reason we mix and match is because let's start with this. The starting vector, which will be this one. Now we only want the side-to-side vector. We don't want the forward and backward vector because it would mess things up. So we'll only take the side-to-side vector or the side-to-side position of the boom, and we actually place it on. We actually take the other the X and Y, or the X and Z rather, from the player, because then they can sort of move together. The back end I don't really care about, so it's just X minus 15 meters basically. On the other side, we have this. Now this is really complicated, whereas all I really technically needed was to do minus times by -4, I think that is, and then add them together. Well, what this is doing is creating a matching version of the collider boom that is inverted. In fact, rather than trying to show you this, why don't I just set this up? So we have a red collider and a blue collider. The red collider is the one that's in front of them, and the blue collider is one that's behind them. So you can sort of just about make this out here. Wait for them to disappear. So if I walk, you can sort of see the lines are that far away. But if I look up, lines come together. So they pretty much just invert when I move like this. And yeah, so the reason why that was important, as I explained previously, that it was trying there to stop it. So we then take these vectors, we take vector 1 and vector 2, then feed them into these two line traces, which we then take the results from and just take the distance. These are really big boxes that we're just taking the distance from. It's fun. Firstly, we are checking if it's side on. That we'll come back to later to say why. It's because we'd have 8 of these boxes otherwise. I probably could do this another way, but timelines are annoying. So yeah, the reason why we have 2 of these boxes is because we're taking 2 different lines. Firstly, we want to compare them and see which one is shorter, because we want to use the shortest value to move the camera, because that will override anything else that's going on. So in this case, we take the distance from one, the distance from the other, compare them. If the input, which in this case is the first one, which is the front one, if the front one is shorter or equal to, we'll use this one. If it is greater than, we'll use this one. And then all this does really is we have our time and we have a float equal to the time, and this is all set up so that it's the longest distance the ray trace can be is set to the lowest camera angle, and almost the closest we can be is the highest angle. So in this case, it's over the top. The reason why we have this is because sometimes you can end up with situations where if the camera length is if the ray trace doesn't hit anything, it just reports 0, and so the actual 0 length is the same value as the highest length. So yeah, now, where have we gone? Here we are. And then we just, so that timer, it basically adds to a thing. We turn it into a vector. We then break that vector into just the y coordinate, and then we take that y coordinate and turn it into a rotator. Then set our camera rotation, or the camera arm rotation, based on that. A lot of that was done previously, but the update was just to make everything work together. Now then, the text typer. This is partially based off of a YouTube video that I've recently watched, or watched today even. But upon making it work, I discovered that it didn't work. So I had to change things around again. Now, let's see, where would this be? This is going to be... So first we're going to boot up this, which is our dialogue. Now, previously, what we did is we actually just had a text box, and we just update the text box directly. This no longer works because of the way that I'm rendering the text. The way that I'm producing the text on screen, I can't make it type if I'm just using a text box. So we've now got a wrap box, which is the same type of box as we used for the inventory earlier. So this is the complicated system that we use for the dialogue. Now, pretty much everything below here you don't need to worry about, because this is all from the dialogue system. But up here is what we are doing. So we'll just run through it anyway though. So we basically take this, we'll check if it's this active context, we check if we are currently in a dialogue. If we are, then we go up here. If we are not, we get rid of it all. So as we are, we're going to follow this line up and get to here. We firstly check to see whether or not there is a text box currently active, and we do that by checking if the active node is equal to a variable that we set later. So if it is true, if it is equal, we can ignore everything up there and we just go on to the rest of it, which I'll come to in a second. But if it's not, if the active text box, the actual value is ridiculous, so it can't ever be true when we start the game. But so if it's false, we basically come to here. Firstly, we check if there's already a text box. Because this here is, we create a text box and stick it here. If it is here, we remove it. If it's not here, so it doesn't bug, we just skip out the removing bit, because it'll say, oh no, we can't find it. So we create a new text box based off of our dialogue widget, which is this. And all this is this it's just a text box. The graph is what's important, and we'll get to that in a second. We'll create the box, we'll set our variables so we can check against it later. We then add it to the actual box that we set up earlier, and then we set the value of this integer to the same value as the active node. So now when we come to check it, we can always just check, oh, is it against it? Yes, it is, keep going. The reason it does this is because it's from here. if this item in the dialog says, oh, we're not the same, we then go through and change it all. And finally, this is to solve a bug that happened when I was texting it. But let's move on to the dialog box. Okay. Now, the reason why this has got to be in a separate box, it couldn't work in the stop, is because this is running on event tick. And for some reason, it doesn't like running the text typing tool in event tick. It wants to run it in event construct, possibly because of the way we delay everything. Now this will be, we're going to go into deeper levels after this, but so when we make our new text box, we run this code. So firstly, we'll go and we'll grab the active context once again from the player. We then gain the text that's currently active, and we turn it into an array of character strings. So basically, every single character we type into the actual text box gets turned into a array. So we now have a length and so forth. This is where things get complicated. So this is a macro which is used to run all of this. So firstly, we take our variable that we're going to be using to actually write this box out, and we set it to blank. We also set the type in integer to blank, because we'll use this integer to say which character we're currently on. And finally, we have our text speed. This is basically the update on how fast the whole thing is, and we run this one twice. So with that all done, we then start our sequencer. So this sequencer, as you can see, has another line coming into it from here. This is our ball at the end, which we check against. And in fact, I'm going to start running from there, because we have the array that we've just sent in. So we have the number of characters we have in our value. We have a length of that, which returns integer. We add 1 to it to make sure that we do get the final letter. And then we have our integer, which we previously set to 0. Every time in the sequence, we plus 1 to the integer. And then if the integers are equal, or to equal plus 1, we then say, we're done, and we shall set it complete. If it's not complete, we come back to the sequencer again and run the first, which is to set the text. We'll show you that in a second. The way that this works after that is we have our array. We will get the specific letter we need based off of the integer we're currently on, because once again we added 1 to it every single time we skip through, and this is here. Once we get the next letter, and we will add it to our current one. So in the first case, we run in, we set it to blank, we then send text box blank, then we set to here, we set the string, because it's blank, we just take the first integer, because it's still on 0, we haven't updated it yet, and we'll take the first letter, add that, and then run through it. Now that we've run through it, it'll send the text out. And we'll do that over and over and over again. This here is a delay, which means that each time we run it, it will pause, so there's a slight delay between each letter being typed. So when we come back out again, we have our set text. So we then send out a text to the target. This will be written. And when it's done, we run is done. I believe that's because, in fact, no. So previously we would then check if it was done, but then we just decided that actually just checking if it's active is the better way to do this. Finally, we have, so once it is the same, we constructed it, we actually start to write our, these update options. These are basically activating the buttons that you want to press. Now, I don't want these to be run right away, because I don't want the buttons to be I don't want the buttons to be active while the text is still typing and allow for the player to skip. So we stick a delay in, which is basically the length of the string we currently have active with times by the text speed to give us a delay. It's actually times by 2 because it needs to be going on twice for some reason. So because of the delay, our isValid check actually then broke. So we now have to stick in a new isValid check. So check, make sure it's still valid. If it is still valid, then we'll add in the loops. And And so, yeah, that basically runs to there. And that's the extent of it. And wow, did this end up being a very messy video.